Hi everyone, welcome to the Mr. X Mathematics Free Mahala lesson. We are doing the topic Euclidean geometry. That's what we're going to be doing. And I want you to understand that Euclidean is a very important topic. It stretches from grade 10 all the way to grade 12. Now, in grade 12, when you write your Euclidean, it will include what you did in grade 10, grade 11, and also what you will do in grade 12. Those that are doing grade 11s, it's important to understand that whatever we do today or for Euclidean is also examinable in your final matric exam. So take this very seriously. Euclidean happens to be the second biggest topic after trigonometry. So trig is the biggest and Euclidean is the second biggest topic. So you must work hard to understand it and work it up from there. So this is the free lesson from Mr. X and welcome. But just as a heads up, I've got more to offer. Apart from the free lessons, this is what I will be doing for the month of April right there. So I teach both mathematics and physical sciences, grade 11s and grade 12. So this is the schedule that we're going to have for this particular month. And I'm excited to announce that it's going to be the craziest topic ever, things that we need to do and understand, and we will be fine with them as we go along. So if you would like to be part of these classes, they happen Monday to Thursday. Monday and Wednesday is grade 12. Tuesdays and Thursdays is grade 11 from there on. So if you'd like to be part of them, please do contact me, because these ones are 50 Rand for a 2-hour lesson. They take place between 7 p.m. to 9 p.m. They are they're 2 hours long, and so they take place from 7 to 9. And then on Mondays and Tuesdays, it's mathematics. Monday, grade 12 mathematics. Tuesday, grade 11 mathematics. Then Wednesdays and Thursdays, it's going to be physical sciences, grade 12 physical science on Wednesday and grade 11 physical science on Thursday. So it's going to be quite exciting, so that we're going to be able to learn quite a lot. And these are the topics that are happening. So that you may know, in terms of how my lessons go, you must pay for a minimum of 2 lessons at a time. Some opt to pay for the whole month. And if you'd like to pay for the whole month, that's going to be 250 for this particular month of April. 250 because I'm going to do 5 lessons for maths and then another 5 lessons for physical science. So per subject, it will be 250. If you want to pay for both of them, it will be 500 rands. But if you want to pay them in bits and pieces, you're only allowed to pay for 2 lessons at a time, 2 lessons at a time. If you want to pick it up into bits and pieces, here's my number, 073-974-8498. So goes the story, and that's how we're going to be rolling. All right, perfect. Let's get down to the business of the day. What are we doing? Euclidean geometry, part 1, which is a combination of what is done in grade 10 and also what is done in grade 11. Please do note that, like I said on the schedule, I am going to do Euclidean, so which means I'm not going to finish all the Euclidean in this lesson. It's impossible anyway. So what I'm going to do is to make sure that I'm going to do the other parts in the scheduled lessons there. Very helpful. People are passing, people are understanding, and it's a beautiful thing that we're doing. We're changing lives and changing your marks, one cheap lesson at a time. Very affordable. That's 50 Rand for a 2-hour lesson, but you can only do a minimum of 2 lessons at a time in terms of payment, or you can pay for the whole month, which is all up to you. Okay, let's start Euclidean. Now we start with the basics, just the basics understanding. This will incorporate things we did in grade 8, grade 9, grade 10. Just want to show you the basics one by one so you can see what's going on. All right, the first one, here we go. Angles around a point, they add up to 360. This is very important. So if you have a point right there, the angles around that particular point, when you add them, they should give you 360. In other words, I'm saying A plus B, then plus C plus D, and I learn that all the angles around a particular point, when added, will give you 360. These basics are very useful when we start doing the questions. All right, let's go for more basics. Vertically opposite angles are equal. Vertically opposite angles are equal. So here we go. What it means, therefore, is that when you have a typical situation like this, notice that angle N here happens to be vertically opposite angle M. Even the colors match. Angle A for angle B. And then in here, this angle is 145. Vertically opposite it, 145. This one goes for 35. Vertically opposite it, 35. So from the basics again, I learned that vertically opposite angles are equal. Keep that in mind. Do not forget that. Vertically opposite angles are equal. More basics. These things you learn even in grade 6, grade 7. Angles on a straight line, they add up to 180. So when angles are on a straight line, they eventually add up to 180. So in other words, if I was to think about it, this angle A plus this angle B plus this angle C, when you add them on a straight line, they should give you 180. Even the diagram on the right-hand side, there's an angle from here to here. It's 30, as you can see for yourself, from there to there. Then the green one, from there until the straight line, is 150. And if you add the 150 and the 30, you end up with 180. Again, angles on a straight line, they always add up to 180. Basics after basics. Interesting ones. Parallel lines. Now, parallel lines are lines that are the same distance apart and they never meet. So these are lines that are the same distance apart, but these lines will never ever cross each other. They will never meet. Once lines are parallel, then the following properties apply. The first one is that when two lines are parallel, you can find corresponding angles. Corresponding angles. Let me explain how you would get that. So here's line A, okay, and line A is parallel to line B. Now, there is an angle, which is angle number 1, and I usually say angle number 1 is at the top of line A. Angle number 3, as an example, is at the bottom of line A. Also, angle number 8, as an example, is at the bottom of line B, while angle number 6 is at the top of line B. Now, when two angles are corresponding, it's top, top, same side. Bottom, bottom, same side. So it's top, top, example, top, that's the angle 1. Top, that's the angle 5. They're on the same side. So angle 1 in this color is equal to angle 5 in the same color. So it is top, top, same side. Or look at angle 4, bottom, Look at angle 8, bottom, and they're all on the same side. So when dealing with corresponding angles, it's top, top, or bottom, bottom, same side. This is very important because when you're dealing with questions between parallel lines, you must be able to recognize that 2 right here is at the top. It's a pink color. Then 6 right here is also at the top and it's a pink color, and they are on the same side. 7 right here at the bottom, 3 right here at the bottom, but same side, so they are equal. Top, top, bottom, bottom, same side. That's how you know they are corresponding. I did put a couple of examples also on the right-hand side. W, bottom, same side. Y, top, same side. Z, bottom, same side. And finally, X, top, same side. Top, bottom, same side, corresponding angles. I want it to be clear that you can never say angles are corresponding unless you have confirmed that the lines are parallel. The properties of parallel lines are corresponding angles, as I have said this. So it doesn't mean that when you got 2 lines, there will always be angles that are corresponding. That's not true. This only happens if the lines have been certified to be parallel. Let's try alternate angles so that it becomes easier for us to understand. So when it comes to the issues of alternate angles, it's top, bottom, then opposite side, or bottom, top, opposite side. Top, bottom, opposite side. Say, help us to understand, what do you mean? Angle 1 is at the top. Angle 8 is at the bottom. And they are on opposite side. 1 at the top, 8 at the bottom, and they are on opposite sides right there. 1 at the top, the other one at the bottom, and they are on opposite sides, so they are equal. Look at angle 2. It's at the top as well, right there. And then look at angle 7. It's at the bottom, and they are on opposite side. So that's how you know that they are definitely alternate. I have a question. Angle 3 is alternate to which angle? You tell me. Angle 3, I need an answer from your chart there. Angle 3 is alternate to which angle? Some are saying 6. I agree completely. This is because 3 is at the bottom, 6 is at the top, and opposite side. Thank you for your beautiful answers. Now, angle 4 obviously will now be alternate to angle 5. So, alternate angles are a property of parallel line. Let's keep going. Co-interior. Co-interior. So, when lines are parallel, it's also possible that you find what are called co-interior angles. Now, the basic idea is that when 2 angles are co-interior, they add up to 180. In mathematics, when angles add up to 180, we say that they are supplementary. Supplementary add up to 180. If they add up to 90, they are typically complementary. All right, so here is y, and then y is on the same side with x, and then they added, they give you 180, even this one here, plus that one there. Co-interior angles are supplementary. All right, let's do some small linear example here, some small linear exercise. So I'm going to say something, you guys will then answer me in the chat as well. Angle A corresponds to which angle? Let me start with the corresponding angles here quickly. Corresponding angle A, let me start there, corresponding. All right. Angle A corresponds to which angle? Let me hear you guys. People are saying G. Let me confirm top. All right, say top. All right, same side. I agree with you. Angle A is equal to angle G. Angle E is alternate to who? Angle E is alternate to who? You tell me. E is alternate to who? I need to hear people talking. E, so E is at the bottom, all right? People are saying, some are saying B, some are saying C. Let me hear what people are all about. If I think about it, angle E happens to be at the bottom. I need angle B is also at the bottom. All right? I hear you. I hear you. Some are saying B and some are saying C. I'm asking angle E is alternate to which angle? Yo, guys, your answers, there are so many. Now some are saying A. Now some are saying C. So let's go through this together. All right, let me help you to understand this. Now hear me out. Look at it. AE is at the bottom. When it comes to alternate angles, I say it top, top, bottom, bottom, same side. I need, right? When alternate angles, sorry, it's top, bottom. They must be different. If it's corresponding, it's top, top, bottom, bottom, same side. But if it's alternate, I've got E at the bottom. Whatever it corresponds to must be on the other side and at the top. And the answer is A. So angle E is alternate to angle A. Now I've got a question again. Why is D equal to B? Give me a reason. Why is D equal to angle B? What could be the reason that D is equal to B? People are saying they are typically vertically opposite. Completely agree with you. It's beautiful. We are learning. You tell me, angle C plus F. Angle C plus F, what should it be equal to? And give me a reason. Angle C plus F, what should it be equal to? And give me a reason. Somebody says 180, completely agree. What is my reason? Co-interior angles. I completely agree with you. Co-interior angles. You tell me more. H. What is H corresponding to? What is H corresponding to? H corresponds to who? You tell me. H corresponds to who? All right. People are saying, say, H corresponds to B. Can I confirm? Yes. Because what? Because H is at the bottom. B is also at the bottom. They are on the same side. So H is equal to B. What is H alternate to? What is H alternate to? What is H alternate to? You tell me. What is H alternate to? Some are saying F. That cannot be F. But some are saying D. I completely agree with you on D because H is at the bottom. D is at the top. And they are on opposite sides. So therefore, they are alternate angles right there. Notice as well that eventually B will become equal to D because they are vertically opposite. So it's important to understand this. Last one quickly, G plus F reason, G plus F reason, G plus F reason. You tell me. G plus F reason. Okay, let me hear what people are saying. 180 angles on a straight line. 180 angles on a straight line. I completely agree with you. So basically, this is what happens when lines are parallel one to another. Let's quickly go to the properties of triangles. I'm almost done with the basics. Then we can go to the theorems one by one. Properties of triangles. Let's do the maths of it. Now, when it comes to triangles, there are different types of triangles. I guess the most popular of them all is the right-angled triangle. Why is it right-angled? Because one of the angles is equal to 90. It's right-angled. Why? Because one of the angles in them is equal to 90. So there are certain properties about a 90 degrees triangle. I will deal with them later. But for now, please understand that a right-angled triangle is a triangle where one angle is equal to 90. Then there is what is called a Scaling triangle. A Scaling triangle. This one has the following properties. No angles are the same. So if this was angle A, this was angle B, and this was angle C, A will not be equal to B, neither will B be equal to C. None of the angles are the same. Further on, no lengths are the same. In other words, this side is different from this side, is different from this side. This is a Scaling triangle. No angles are the same, no lengths are the same. Then on the flip side, you've got probably the most popular triangle in this topic, the isosceles triangle. Now, this triangle has the following properties. In an isosceles triangle, two angles are the same, and then as well as two lengths are the same. So let's say this is angle A, this is angle B, and this is angle C. It would mean, therefore, that, let me call this side A, B, C, for clarity's sake. All right, it means A, B, and I see this by this stroke here, is equal to AC. So the two lengths are the same. And because the lengths are the same, then the angles, and which we go back to grade 8, grade 9, they would say the base angles of an isosceles triangle are equal. So I would say angles opposite equal sides. Now, I want this to be understood that way because that's how they want you to write it in your exam. You see, angle B, small letter b, is opposite side AC. Angle C, small letter c, is opposite side AB. So it means angle B, small letter b, and angle C, small letter c, they are both equal because they are angles that are opposite equal sides. I want this to be remembered. All right. So you say to yourself, they are angles opposite equal sides. Somebody is asking, let me read. In the exam, would they still indicate the equal sides with the strokes? Yes, they would. These strokes stand for equal sides. And because AB, the side, is equal to AC, the side, then the angles, angle B and angle C, are now angles that are opposite equal sides. The most popular in this topic, the isosceles triangle. The last one on the bottom left corner is the one that went to a private school. Model C's type of triangle was brought up in a family where there is a mother and a father, and they're both working and they have money, they have inheritance, there is everything. It's the perfect triangle, equilateral triangle. What's happening right there? All the angles are the same, or rather, all the lengths are the same. Perfect family, perfect child, perfect childhood. Equilateral triangle. This is a triangle whereby I know that side AB is equal to side BC is equal to side AC. All the lengths are the same, and this angle A and this angle B and this angle C, all the angles are also equal, equilateral triangle. So these are the triangles that you have when you are dealing with this particular topic. But let me add more basics, family members. Let me add more. Typically, when you've got a triangle and that triangle happens to be right angled, grade 9, grade 10, happens to be right angled, like for an example, this one here, it's a right angled triangle. What it will ultimately mean is that there is the application of the Pythagoras theorem. There is the application of the Pythagoras theorem. In the Pythagoras theorem, basically you are looking at this side, which is opposite the 90, side C. In trig, would have called this the hypotenuse side, the side that is opposite to the 90. And then Pythagoras says this side opposite to the 90, this hypotenuse side squared is equal to this side squared plus that side squared, the Pythagoras theorem. Super important that you remember this, super important that you understand this as well. All right, so that's the Pythagoras theorem. It happens or it works only if you are in a situation whereby you've got a right-angled triangle. Perfect. Let's go further. Relationship between angles. Relationship between angles. As probably you know or have recognized, the sum of angles in a triangle, they add up to 180. So all the angles in a triangle, they add up to 180. So if you were to write it as a reason, you would say the sum of the angles in a triangle is always 180. Angle A plus angle B plus angle C, when added together, they should give you 180. Please do remember that. Then a very important one, and I love this one, the exterior angle theorem. Let me read it first. It says, the exterior angle of a triangle is equal to the sum of the two opposite interior angles. One more time, let's read what's going on. It says to me, the exterior angle of a triangle. Exterior means outside. So the outside angle of a triangle is equal to the sum of who? Of the two opposite interior angles. Sum of the two opposite interior angles. Now, just in case this messes you up in terms of understanding, let me help you to see which one is relevant. D is outside. Let me put an extra angle here, and I'll so call this angle E. Now, listen to me. A inside, B inside, E inside. A plus B plus E is equal to 180. That's very true. But look at D and E. So D plus E is 180. My reason is the sum of angles on a straight line. For the first one, A plus B plus E is equal to 180, is the sum of angles in a triangle. Then the theorem says the outside angle, D, who is D equal to? A plus B, there. But I want you to know, because some of you guys make a mistake. Sometimes you say D is equal to A plus E. That's not true. Sometimes you say D is equal to E plus B. That is not true. Never, ever, ever use the angle next to the exterior. Never. You must never. D is next to E. Never use the one next to the exterior angle. Use the other sides. Use the other guys, so that D outside is equal to the two interior opposite angle. It's not A plus E. Don't be Chuck Norris. It's not B plus E. Do not be Chuck Norris. It's going to be D on the outside is equal to A plus B. Your reason, exterior angle of a typical triangle right there. All right, I hope people are understanding and you are seeing this, because when it comes down to the wire, we're going to be using all these basics and these typical situations to answer our question. Almost done. Let's talk about a circle very quickly. Now, I want us to understand typically the parts of a circle, particularly the most important parts of a circle. This is because the grade 11 theorems, they deal with the circle. The grade 12 theorems deal with a triangle. So grade 11, the circle, grade 12, the triangle. Okay, perfect. So hear me out. So you've got the following parts, which I think are super important. For the most of the part, we've got the center, which I really want to just make sure that I show it there. This is the center of the circle. The blue line is the diameter. The blue line is the diameter, which is basically the distance from one circumference. So the circumference is the border of the circle. So this is the circumference, the borderline of the circle. So then when you're talking about the blue line, you're saying a line drawn from one circumference to the other, passing through the center. That's a diameter. From one circumference to the other, passing through the center. That is a diameter. For the radius, it's from the center to the circumference. Please remember that. For the radius, it's from the center to the circumference. The diameter is actually twice the radius. So if the radius was 5, the diameter of the blue line would be 10. The diameter is twice the radius. Very important that you understand this, and we pull through from there on. Then another important part of a circle is the chord. Now the chord is a line that is drawn from one circumference to the other circumference, but does not pass through the center. Keep that in mind. From one circumference to the other circumference, but does not pass through the center. That is very important that you understand that. Does not pass through the center. That's a chord. It is different from a diameter, because in a diameter, we would know that because it passes through the center. I'm showing you parts which are super important and that we're going to use for our theorems. And then lastly is the tangent. You'll notice that some parts I won't talk about them because we don't really use them much in this particular topic. The tangent. The tangent is drawn outside a circle. The tangent. Drawn outside a circle, and it passes through one point on the circle. So it's drawn outside a circle, that's true, and passes through only one point on the circle, tangent. So please remember that as well. Now, what I've just mentioned, all our theorems for grade 11 are built around these parts, the radius. They are built around these parts, the diameter, the chord, and all that, and C, and from there on. So in terms of how you would then put it across, and I'm just reading a question, why is a chord not passing through the center, but a diameter does? That's actually the difference between a chord and a diameter. A diameter passes through the center, a chord doesn't. If there is a line that passes through the center from one circumference to another, then it would mean that it is now a diameter. A chord, by definition, does not pass through the center, though it's moving from one circumference all the way to the other. Tangent, one more time, straight line outside a circle that passes through only one point. Very important that you understand this, because when I teach you guys the topic analytical geometry, which is also a grade 11 topic, but examinable in grade 12, when I teach you that topic, the word tangent will come through. For those doing grade 12, you do tangents in in circle geometry. You also do tangents in cubic graphs. So good luck as we learn together. All right, I'm ready to now go to my next ones. Here we go, family members. We're now starting with the theorems. The theorems right here. Now, in the theorems, from there on, I want you to understand there are about 9 of them. Hopefully I can do all 9 today. If not, I will finish up on my paid classes. Guys, my paid classes are fire. The types of questions that we do there are fire. And I've tried to make them very affordable. So attend them, they will help you. Let me start off with theorem number 1. So in each theorem, I'm going to state what it is. Then I'm going to do questions on that particular theorem. Theorem number 1, here we go. We begin, we start together. Theorem 1. It says to me, the line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. Let me read that again. Theorem number 1. It says a line drawn from the center of a circle to the midpoint of a chord. What about it? That line is perpendicular to the chord. Here is OP. It's a line drawn from the center. P happens to be the midpoint of the chord AB. So AB, you are a chord. is the midpoint of the chord AB. OP is a line drawn from the center of a circle to the midpoint of a chord. And theorem number 1 says that line is actually perpendicular to the chord. This helps me to understand that if I have a situation whereby I have this particular line OP and is drawn from the center to the midpoint of the chord, then it means the line OP is perpendicular to the line AB. These theorems can be proved. In today's lesson, I'm not teaching you the proof of theorems. I'm not going to do that. What I am going to teach you rather is how to use these theorems. On my paid lessons, I will teach the proofs and do even crazier past exam kind of questions. OP perpendicular to AB. That's the first part of writing theorem 1. But there's another way to look at theorem number 1. It says the line drawn from the center of a circle perpendicular to a chord bisects the chord. I read that again. The line drawn from the center of the circle, there's my line OM, and they say OM is perpendicular to the chord, and I can see that there's a 90 degrees, because if lines are perpendicular, the angle between them is 90. So OM right there is perpendicular to AB. And then it says because of that, then it bisects the chord. To bisect anything means to cut it into 2 equal parts. So it means, therefore, line OM, which is perpendicular to AB, will bisect the chord AB such that AM is now equal to MB, such that the center is now M, midpoint. So it's another way of looking into this whole thing from there on, right? It's another way to look into this whole thing from there on. So I want you to remember that. It's a line drawn from the center of the circle, perpendicular to the chord, and ultimately it bisects the chord. All right, now that we know this, now I can do the theorems. Let me just go through this one more time. Listen to me and tell me where the problems are, because I want to use this theorem to answer questions. Here we go. Basically, again, when you've got a line from the center of the circle and it goes to the midpoint of a chord, then that line is perpendicular to the chord. It means OP is perpendicular to AB. So it means here, the angle will be 90, and even here, the angle will be 90. The other way to look at it is to say the line drawn from the center of a circle, so from the center of the circle, and that line is perpendicular to the chord. What does it mean? It means that line bisects the chord. So to bisect means to cut into 2 equal parts. That's what bisecting means. So by virtue of the line OM being perpendicular to the chord AB, therefore, from this theorem, I can conclude that AM is equal to MB. Line from center of the circle perpendicular to the chord bisects the chord. Let's do questions. I'll start off with this one. I need your help because we're going to do this together. Questions on theorem number 1. I will also upload this lesson on YouTube so you can watch it later on and be able to pull through. Questions on theorem number 1. Let me begin. It says to me on this one, in the diagram given alongside, O is the center. So it's important to read and understand. So O is the center. Okay, I'm okay with that. And that one says OB. So the length OB is 6 centimeters. Then they told me that OC is 10 centimeters. And they also tell me that OB is perpendicular to AC. And so to begin with, the question says, calculate the length of AC. Calculate the length of AC. Let me start off. Let me help you to understand this. Calculate the length of AC. So it's important to write what you know and to give reasons as to what you know. And I need your help in all of this. Remember, I'm looking for the length AC, which is a chord. Okay, so OB is perpendicular to AC. This one we are given. So this one we're given, we can see it, OB perpendicular to AC. And when I go back to my theorem, it says if a line is drawn from the center of the circle and then it is perpendicular to the chord, then that line bisects the chord. So I can continue and say B is actually a midpoint. So B is the midpoint of who? Of the line AC. So B is the midpoint of the line AC, meaning that AB would be equal to BC. But why am I saying B is the midpoint? Reason, line from, I need to write this down, center perpendicular to the chord. But what am I looking for? AC. So notice something. If I find BC, for an example, then I can find AC. If I find BC, I can find AC. This is because OAC is twice BC. I need to say B is the midpoint. So AC is twice right there, BC, because B is the midpoint. So AC is twice BC. Okay, sharp, no problem. Now, how then could I find BC? I think I see what I see. Triangle OBC is right angled. So we can use Pythagoras theorem. So Pythagoras, 10 squared is equal to 6 squared plus BC squared. And you must always have a reason. Maths 100, maths 36 plus BC squared, that's 64. Maths is equal to BC squared. And eventually, at the end of the day, right? At the end of the day, you're going to find out that BC is equal to 8, but that's not what you're looking for. You're looking for AC, which is twice that. Therefore, the value for AC is 16 centimeters. We start small, all right? We start very small, nothing too hectic. Talk to me. Are we together? Are you guys still able to hear me out? Just want to confirm that. All right, perfect. So people are still able to hear me out. I'm happy about that. Let me go to my next one. Please write this down. Let me go to my next one. I keep building up my story and I keep making it even more challenging over and over again so that people can understand. We start small. Like I said, we start very, very small. Very, very small. Right. So somebody says, say, is it a must to use centimeters or we can use units? In this case, because they gave you in terms of centimeters, all your lengths or centimeters, that's why I used centimeters as well. If they don't, then you would write units. Taking this out now, gone, gone, going, gone, I am gone. All right, perfect. I'm ready for the next one. Here's another question, but this time I want us to attempt it together as well. And let's see how far I can go so that we can take it up from there. Okay, here we go. Somebody's asking, let me go back. Say, why is BC twice AC? It's because B is a midpoint. Because B is a midpoint there. I need to B is a midpoint because OB is perpendicular to AC. Now B, midpoint, point in the middle. So what it means is that if B is a midpoint, then it means at the end of the day, AC is twice. Because if this was 5, then AC would be 10 because B is a midpoint. Thank you for the questions. Here we go. AB is a chord of a circle. All right. AB, it's a very interesting question that we're going to do now. AB is a chord of a circle right there. And it says OE bisects AB. OE, there's my OE on the diagram. It bisects AB. Then they told me that AD is 12, ED is 8, and OD is X. Determine the radius OB in terms of X. Determine the radius OB in terms of X. All right, I need to hear people talk to me here. If you do understand or don't understand, I will definitely help you. Okay, let's discuss here. You see, OB is a line drawn from the center to the circumference. So OB is a radius. Even OA is a radius. Even OE is a radius. So I want you to see who the radiuses are. The radius is OB, I agree. The radius is OE, I also agree. The radius is OA, I also agree. The question starts off and says, determine the radius OB in terms of X. All right, I'm ready for that one. So we said OE is equal to OB is equal to OA because all of them are radii. Don't say radiuses. Nantwana. Wrong English. Radii. Radii. That's how you put it. Notice that they want OB in terms of X, but OB, which is a radius like OA, like OE, they told me that ED is 8. Perfect. Then I know that OD is X. So which means OE, follow me. OE is X plus 8. All right. I will say, what do you mean? OE is X plus 8. Right? So OE is a radius because it's drawn from the center of the circle 9 to the circumference, radius. OB from center to circumference, radius. OA from center to circumference, radius. And OE is 8 plus X. So therefore, OB, I'm answering question number 1, which is radius like OE, will just also be x plus 8. That's my answer, so that it becomes easier from there on right there. All right, guys, I'm slow. Trust me, I'm slow. You have no idea how slow I am. I'm very slow. All right, because normally I speak faster than this and I move faster than this. So that's number one. OE is equal to OB is equal to OA. All right, I'm ready to move on to the next one. Let me just reiterate this. Like I'd said prior, please listen to me. Like I'd said prior, you need to know the parts of the circle. And in the parts of a circle, basically, you're saying to yourself, this is a radius, and on EO or OE, if you want to put it, so on OE, OE is made by the line ED and the line DO. So OE, you can call it EO if you want, but I'm going to say OE is made by the line ED, which is 8, and the line DO, which is X. So there at the end of the day, it means that your OE is 8 plus X, but I always like to put it as X plus 8. And OE is like OB because they're all radius. They are all radius. Come on, guys, let's move, okay? Let's move. Let's move, fam. Be in this lesson. It's not difficult. Be in this lesson. Be in the lesson. You'll be fine. You'll be fine. Listen to me. All right, let's move. We need to move. We've got a lot to cover up. All right, I'm ready, and I'm taking this out. Then the next question then says, hence, calculate the length of the radius OB. Hence, calculate the length of the radius OB. Okay, let's write what I know. We know that D is a midpoint because they told us that OE bisects AB. So D is a midpoint. From what I learned that if there is a line drawn from the center of the circle and it is going to the midpoint of a chord, then that line is perpendicular to the chord. In other words, OD is actually perpendicular to AB. And what's my reason? Line from center where to midpoint, right, of a chord. So that line is perpendicular to the chord. That's still theorem number one. Line from center to the midpoint of a chord is perpendicular to the chord. The question says, hence, calculate the length of the radius OB. Okay, now DB, I write what I know. DB is 12 centimeters. Anita, they said AD is 12. So DB is also 12 because D is a midpoint. So DB is 12. Now, OB, we say it is X plus 8. That's what OB is. It's X plus 8. And I don't know what X is. So currently, I know that now the angle here, D is 90, because line from center to the midpoint of the chord is perpendicular to the chord. So the angle here is 90. So let me concentrate on the triangle where there's OB. Right, let me call this triangle ODB. This one, ODB. Using Pythagoras theorem, OB squared is equal to OD squared. There you are. OD squared plus DB squared. And my reason is the Pythagoras theorem. All right. What is OB? OB is x plus 8. So OB squared. OD is x. So x squared. DB is 12. So 12 squared. I think I see where I'm going. I just need to find x and I'm good to go. The brackets are opening now. I need your help. So let's get our calculators ready. I need your help. In all of this, this becomes x squared. This is 144. So I do the maths. X squared, I'm foiling, plus 8x plus 8x plus 64. All this is equal to x squared, then plus 144. We do some maths together so we can see what's going on. This becomes x squared plus 16x plus 64. All this is equal to x squared plus 144. Now, the rest is algebra. I'm looking for x. I want you to get involved. Please find the value of x. Please find the value of x. People are saying 5. Okay, after doing the maths, people are saying, say, x is equal to 5. I completely agree with you. After doing the maths right there, the value of x is equal to 5. So then at the end of the day, you're looking for OB. And what is OB? It is x plus 8. What is x? It is 5 plus 8. So finally, the value of OB is equal to 13. The value of OB is just equal to 13. So beautiful. Love it. Please write this down. That's my second question. Let me go to my third one. I'm going to give you the third one to try. It's a past exam paper. I took it from a grade 12 past exam paper. I'm going to give you about 3-4 minutes to try. When you're done, we'll do it together. Then from there on, we go to theorem number 2, 3, 4 as persists during our lesson, our free lesson with Mr. X. I'm going to be sending my YouTube link right now on the chat group as well. Finish writing this up. I'm about to give you a question to try on your own. Thank you for writing and getting X is equal to 5. I'm ready. I'm ready. I'm ready. I'm about to take this out right now. Yeah, man. Maths is fun. Maths is beautiful. Okay? Study it, understand it, work on it, dedicate yourself. You will be fine. Okay. People are done. People should be done. Taking this out. You can even take screenshots of this, fam. Still okay. You just simply take a screenshot. Nothing hectic. All right. Gone, gone, going. Gone, gone. Perfect. Here's my question. It's from a past exam paper. It was a 2014 prelim paper. It's a grade 12 paper, but it's covering grade 11 content. I'm giving you 4 minutes on your own. Let's go. Guys, on your devices, you need to zoom in and out to see the questions because your screens are too small. I'm using a laptop, right? So your screens for your phones may be too small. You need to zoom in and out to see the diagrams. Your Zoom app allows you to be able to do that, okay? So I see something, say scroll down, up. I can't because this is the actual screen. This is what I'm also looking at on my own phone. I've also joined with my phone. So this is what you have. So please make sure you zoom in and out. You can be able to zoom in and out and you can be able to see the question. 2 more minutes. No, keep the answers to yourself. I'll do it now. Now. Right, let's do this together. I want to start. 9.1 says, complete the following so that the Euclidean geometry statement is true. Complete the following so that the Euclidean geometry statement is true. A line drawn from the center of a circle to the midpoint of a chord is, so you need to put a word here, is, and the word is perpendicular. That's it. A line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord. That's 1 mark. 9.1. 9.2, in the circle with center O, chord AB. So the whole chord from here to here, it's 18, and AD is equal to DB. So if AB is 18 and AD, there's a stroke there, DB, there's a stroke there, they are equal, then it would mean AD is 9, DB is also 9. Then they said chord CB, there's my chord CB, is 24. 9.21, calculate the length of CD. Leave the answer in the simplest surd form. The length of CD. It's important when you're writing this to have reasons. And so here's my first one. The angle D is 90. Why? My reason. A line from the center of a circle to the midpoint of a chord is perpendicular to the chord. That's why D is 90. What they asked you to finish off in 9.1 is your reason. So it's a line, okay, from center to midpoint of chord. So that line will be perpendicular. Now, because D is 90, then in triangle CDB, I've got a right angle since D is now 90. Then, therefore, once I have a right angle, who comes into my mind? Pythagoras. CB squared is equal to CD squared, which is what I'm looking for, plus db squared. And my reason is the Pythagoras theorem. 24 squared, that's CB. CD, don't know you. DB is 9 squared. Remember, fam, they told us that AD is equal to DB. So therefore, CD, rather DB would be 9. Since OAB is 18. When you do your final answer, I know this, you're going to get 3 root of 55. That's your CD, 3 root of 55 right there. Okay, that's your answer for 9.22. Let me try 9.21 rather. Let me try 9.22. Right, said, do we mention the centimeters? There are no centimeters. Oh, yes, there are centimeters here. So you don't really get penalized for this. Unlike in physics, but here you don't really get penalized. 9.22, thank you for the beautiful question. If CD over DE is equal to 3, calculate the length of DE. CD from the previous question is 3 root of 55. DE, I don't know you, but all these guys are equal to 3. I'm looking for DE. I can quickly cross multiply. So it becomes 3 root 55 is equal to 3 DE. Remember, I'm looking for DE. And then at your end of the day, DE is now root of 55. So that's your answer. Somebody is asking, say, can we leave the answer as 22,25? No, you can't, because the question says leave in the simplest surd form, not as a decimal, but in the simplest surd form. So that becomes your answer. Let me go to my next theorem so that it's easier for me to work on it and help you understand this. Did you guys get this? Did you get all of it? Give me a yes or a no. I just want to see what's happening on the chart there, so I have an idea if people are winning or not. We're starting from scratch, step by step. I'm not going to be able to finish out everything, but I am definitely going to be doing this whole topic the whole month of April. My word is crazy. It's crazy. 9.21 dribbled me. Yes, no, no, yes. It's okay, family members. We're learning together. We will be fine. Taking this out, gone, going. Boom. That's what I'm talking about. All right. The next theorems use the concept of subtended angles. The next theorems, they use the concept of subtended angles. Let me explain it to you. Please follow me. Now, if we have got a line AB, there's my line. The line is AB. Notice that the angle C, this angle right here, the angle C, is made by a line from A and a line from B. One more time. I want you to understand what it means when they say subtended angle. There's a line AB. Okay, sharp. There's an angle C. So the angle C is made by a line from A and a line from B. So then in mathematics, we will therefore say angle C is subtended by the line AB. In other words, we're saying angle C is made by a line from A and a line from B. Subtended means made from. So angle C is made from the line AB. Okay, look at the second example here. It's a circle right there. Then this one is an arc, the green one, arc XY. There's an angle here. Let me call this O1. So I'll just say O1. So notice that O1 is made by a line from X, there you are, and a line from Y. That's O1, subtended by the arc XY, subtended by the arc, made by the arc. So it's pretty simple. All you need to do is to go to the angle. So I'm going to the angle now. All right, here I am. This is my angle. Then I say, who makes it? Who makes this angle? A line from X and a line from Y. Or in this case, because it's a circle, arc XY subtends O1. And if O is at the center, line or arc XY subtends O1 at the center. So the rest of the theorems are all subservient to the concept of subtended angles. Let's do the maths. Theorem number 2. Theorem number 2 says, if an arc or a chord subtends an angle at the center of a circle and also at any point on the circumference, then the angle at the center is twice the angle at the circumference. Let me help you. Look at the diagram. Then I'll go and read it again. This is a diagram. I'll call this point A. I'll call this point B. I'll call this angle O1. I'll call this angle C. Okay, perfect. Now notice that the arc AB is subtending O1 at the center and also subtending C at the circumference. O1 at the center, C at the circumference. Right, work with me, work with me. Okay, so here's my situation. A line from A and a line from B, they make O1 at the center. A line from A, okay, a line from B, they make angle C at the circumference. So it looks like to me, AB is subtending two angles, one at the center and the other one at the circumference. Both O1 and C are made by the same arc. And so the theorem says, if an arc or a chord subtends an angle at the center of the circle, like O1, and also at any point on the circumference, like C, then the angle at the center, O1, is twice the angle at the circumference. So the angle O1 at the center is twice the angle C at the circumference. So I want you to remember, English, that the big angle is at the center. The big angle is at the center. One more time. The big angle is at the center. How big are you? I am twice as much. Under what circumstances? When there is an arc or a chord that subtends an angle at the center and another one at the circumference. One more time. One more time. Then I'm going to do the questions now. Angle at center twice angle at circumference. Let me go back. Follow my lead. I'll use the same example. Please listen to me. Let me do this. Okay. This is this, and this is that. I'll call this A. Why is it disappearing now? I don't want things that disappear. All right. I'll call this A, and I'll call this B. Okay, perfect. I want you to see that the arc AB is making this angle. I'll call this angle O1. And then I'll call this angle at the top here, angle C. All right. So the arc AB is making O1 at the center. And also the arc AB is making C at the circumference. So the arc AB subtends two angles, one at the center and the other one at the circumference. And the theorem says if an arc or a chord subtends an angle at the center of a circle and also at any point on the circumference, then the angle at the center, this one at the center, is twice the angle at the circumference. So the angle here at the center, which is O1, is twice the angle subtended by the same arc, but at the circumference. So the angle at the center, O1, is, that's why O1 is 2 theta, but C is theta, to signify that the angle at the center is the one which is bigger. It is twice the angle at the circumference. All right, I want to use this theorem in questions now. Step by step, I'll help you to understand. So I'm with you. Let me do 2 or 3 questions and you'll be able to see what's going on. Now, the question says, calculate the value of the unknown variables in each case. And they said in each case, O is the center. O is the center. Okay, I'm happy about that. AC. AC subtends which angle? AC subtends which angle? Come on now. Come on now. AC subtends which angle? You tell me. You tell me. Somebody says O and B. I love it. So you guys are saying the chord or the arc AC rather subtends the 60 degrees at the center and also subtends the X at the circumference. And so they said find X. So X would be 30 because the one that is bigger is at the center. Ne? Thank you so much, family members. The one that is bigger is at the center right there. And so we say angle at center. So you say angle at center as a reason is twice the angle at the circumference. Now, when I do the other lessons later on, I'll show you what they want as shortcut. So you don't need to write the whole theorem. They just want the shortcut. So X is 30. I'm happy with that. Let me try my next one. Going. X is 30. Angle at center twice the angle at the circumference. I'm about to take this out. X is 30. Angle at center twice the angle at the circumference. I even put it out as a statement, put it nicely for you. Actually, that's how they want you to write it in the exam. Angle at center, the reason. So there must be a statement and there must be a reason. There must be a statement, then there must be a reason. Here's another one. You tell me, what is X? You tell me, what is X? Right there. Talk to me, family members. Talk to me. Somebody's saying 48. I hear 48. I'm loving 48. So therefore, X is 48. Look at my reason right there. Angle at center twice the angle at the circumference. Again, you can write this down so that it becomes easier to understand, easier to break it and see what we are doing for ourselves as a team and as a family. All right, I'm ready. Basics on basics on basics. Here we go. Here we go. Talk to me. Talk to me. All right. Talk to me. Talk to me. I hear people talking. Somebody gives me a 20. Do I get a 20 right there? Somebody gives me a 5, a 20. I'm shocked. 5. From where? Oh, yeah. Remember, the one that's bigger is the one at the center. Now, I see some people are confusing this, and I think it's the grade 12s who are confusing this with angles in the same segment. The angles in the same segment only work when they are both at the circumference. This is at the center. At the center. Check it out. AB, or rather right, AB subtends X at the center, and AB subtends 10 at the circumference. So therefore, at the end of the day, my value for X is equal to 20, angle at center, twice the angle at the circumference. Keep writing this, keep checking this out, keep winning with me. Let's take it up from there, step by step. Here we go, here we go. All right. Again, it's all on you, fam. We start small into one. Nothing hectic until you see the past exams, until you come to the next ones, until you see what's going on. All right. Somebody says what? Say, what did you say about segments? I say to you, they only work if both of them are at the circumference. One guy was at the circumference, the other one was at the center. It's just like with this question. 36 is at the center, other one is at the X. Segments only work when both are at the circumference. I hear X is 18. Do I agree? Yes, I do. X is 18, angle at center, twice the angle at the circumference. Theorem number 2, I'm still good to go. Let me see if I got something else here. Yeah. Good luck. 2 minutes. It's all on you. Mangene boy. Mangene boy. You're looking for M, you're looking for X, you're looking for Y, you're looking for Z. Go for it. Those letters, those variables. Oh, sorry about that. Oh, I've missed that. No. Yes. Why am I giving you an answer? Yeah. There you are. One more minute. All right, I'm ready to start. Let's begin. It is important, and if you go back to how the question was structured, they said in all the questions, please note that O is the center. Now, to begin with, OA is a radius. OB is a radius. So this triangle OAB is actually an isosceles triangle. It's definitely an isosceles triangle there, right? And it would mean that the base angles are equal. So therefore, M is equal to 62 degrees. And my reason, it's angles opposite equal sides. They don't want you to say base angles of an isosceles. They don't. They want you to say angles opposite equal sides. That's what they want. So M is equal to 62 angles opposite equal sides, because look at it. M is opposite OOB, which is radius. 62 is opposite OOA, which is also radius. I'm ready. Let's work together. X plus 62 plus 62 is equal to 180. Okay, all right, say, tell us more. You're looking for X now. Yes, I am. So the value for X here plus this M, which we now say it is 62, plus this 62 is 180, a sum of the angles in a triangle. So therefore, X is equal to 180 minus 124, which should be 56. That's what the value of X is. All right. Now I'm looking for Y and then Z. Let's work together. Follow my lead. Okay? Follow my lead. Some of the answers that you guys are giving, they're giving me headaches, Shem. But we're learning. Now look at Z. Z is subtended by a line from A and a line from B. Same thing, Y by a line from A and a line from B. Same thing, X by a line from A and a line from B. So X is at the center, the Y and Z are at the circumference. So therefore, Y would be equal to 28, since X is 56, angle at center, twice angle at circumference. Z is also equal to 28, the same reason, angle at center, and then go on, twice the angle at the circumference. So Y and Z, and I know the grade 12s want to say angles in the same segment. I have not taught you that. Hold it. I've not taught you that. All right? I've only taught you as far as this. So Z is 28. Where are you guys getting 124 from? Where are people? I need questions. Nenzani, what are you doing? Talk to me, fam. I got your back. Please always note the typical arc chord that is subtending. Y is subtended by AB, where? At the circumference. OX is subtended by AB, where? At the center. Angle at center is twice the angle at the circumference. Okay, that's how it is. And even with Z, Z is subtended by AB, X is at the center, so Z is 28, angle at center is twice the angle at the circumference. Talk to me. Here are the comprehensive answers. I have them nicely put on a table. There you are. See? That's what I have right there. Angle at center is equal to twice the angle at circumference. Talk to me. Why are people say okay? Why is half the okay? People are understanding. I'm happy that even in the chat, you guys are helping each other out and all. Okay, fam. Did anyone? Okay, someone's got a hand. Yes, go ahead. I'm listening. I've unmuted you so you can be able to say something. Please go ahead and say it. You're not audible, but your mic is on. You are unmuted, but I cannot hear you. Okay, we'll try it. Maybe type your question because I cannot hear what you're saying. All right, here's another one. Try this. Try this, family members. Try this. One more minute. Come on now. Come on now. You can even chat together on the chat room there. I'm okay with that. I'm happy about that. There are parallel lines here, Antoana. There are parallel lines. I'm ready. Here we go. To begin with, let's start with M. I think M would be the fastest one to get. M should be 22. M should be 22. Your reason is because they are alternate angles. So there are parallel lines. So M right here at the bottom, and then 22 at the top, opposite side. So M is 22, and you say alternate angles. But let me say this, family. Whenever you write your reason and say alternate angles, or even if you say corresponding angles or co-interior, you must then specify which lines are parallel. So M is 22, OB is parallel to AC. Your reason is alternate angles. That's M. Who subtends M? You tell me. Which arc subtends M? M. Which arc subtends M? Talk to me. Which arc subtends M? Somebody says BC. Let me confirm that. So it's a line from B and a line from C. Who subtends N? N. N. Who subtends N? Let me hear who subtends N. a line from C and a line from B as well. So CB. So the same arc is subtending M at the center and N at the circumference. The value of N is 11 degrees. Angle at center twice the angle at the circumference. So N is 11. Let me show it to you because I wrote it nicely here. There you are. N is 11. Therefore, angle at center twice the angle at the circumference. Okay, still on theorem number 2. I'm so happy about this. People are getting this right. We are learning, we're pushing through, we are understanding, and we are working on it. We will be fine. We'll pull through from there. I want to try my next one. I'm going to try my next one. Let's see what the next one is all about. Any questions so far? Any questions so far? You don't need to draw these diagrams because I'll send you this handout on the group. Guys, those that don't know, I have a WhatsApp group. My number is 073-974-8498. Our WhatsApp group is big, man. The grade 12s were 915, and the grade 11s were 845, right? So please make sure that you attend to that. Text me, I will put you on the group as well. Okay, let's go back. So remember, I'll send the link of the group. Okay, I will send the link of the group here as well for the grade 12s and the grade 11s. Just hang in there. Okay, so look at this. I was saying there are people that are still struggling how I got my N. Guys, if I was to tell you a key word in this topic, subtended. Subtended. There's no word more important than that. Subtended. M is at the center. M, center. Who's making M? A line from C and a line from B. Okay, sure. N is at the circumference. N at the circumference. Who's making N? A line from C and a line from B. So therefore, M being at the center and being 22, N at the circumference will be 11, because the one that's big is the one at the center. The same arc subtends both of them. The same arc subtends both of them. M at the center, N at the circumference, angle at center twice the angle at the circumference. All right, that's what you have right there. I'm all good to go. Here we go. Here we go. Taking this out, gone. I want to just go to theorem number 3 now. Theorem number 3 quickly, so that it's easier to understand, to get what we need on theorem number 3. We only have groups for grade 11 and 12 for now, but I will do one for grade 10s maybe later on. We'll see. I'll make a decision. But you have my number that I've just put, 073-974-8498. You guys can be able then to ask me questions, and I'll put you in the groups. Very exciting group of motivated young people that really want to pass maths and physical sciences. Okay, I'm ready. Right there. I'm ready right there. Okay, theorem number 3. If a diameter of a circle subtends an angle at the circumference, then the angle is a right angle. Let me say that again. If a diameter of a circle subtends an angle at the circumference, then the angle is a right angle. Okay, look at the diameter AB. Then there's an angle at the circumference. So the diameter AB subtends this angle right here at the circumference. And so the theorem is saying the diameter will subtend an angle of 90 degrees, which is a right angle, at the circumference. Usually, the reason that we give, we say angles in a semicircle, or you can say subtended by the diameter, they are 90 degrees. So mostly, this is the one that we use. We say angles in a semicircle are 90 degrees. That's what we say. Angles in a semicircle are actually 90 degrees. So let me read that again. If the diameter of a circle subtends an angle at the circumference. So what you need is a diameter. Then you say to yourself, we're not diameter. Who are you subtending at the circumference? The one that it subtends will be 90. Your reason, angles in a semicircle. One more time. A diameter subtends an angle of 90 degrees at the circumference. At the circumference. A diameter subtends an angle of 90 degrees at the circumference. Questions on theorem number 3? Me and you know how we roll, Ndwana. You know how we roll. Let's start. It reads as follows. Calculate the value of the unknown variables, or is the center in each case. PR is a diameter. I think that's very true. I can see that because O is the center and the diameter is the line drawn from the circumference of a circle to the other, passing through the center. Angle Q is equal to 90. Why? You tell me. Why is this angle 90? Why? Why is this angle 90? Thank you. Angles in a semicircle. I agree with you. Because if you look at it, the angle Q is made by a line from P and a line from R. So PR is a diameter and it subtends angle Q. I'm looking for X. I'm looking for X. So then I can now say to myself, at the end of the day, X plus U55, I already see it, plus U90 is equal to 180. Those are angles in a triangle, or the sum of the angles in a triangle. X is 35. That's how your maths would look like. So somebody says, sir, can the reason also be angle subtended by a diameter? Yes. I usually say angles in a semicircle, but you can also say angle subtended by a diameter. So that's your answer. I do have the answer written nicely, properly on a typical table. Oh, I didn't write it. Okay. All right. Let me take it back. Don't worry, I'll get you back what I need. There you are. X is 35. Questions on theorem number 3. I'm ready. I'd like to try the next one. We start small. We build up our story. And we take it out from there. All right, I'm ready. Why is Q90, right? It's because it's the angle in a semicircle. And it's we say to ourselves, the diameter, this is theorem number 3. The diameter always subtends an angle of 90 degrees at the circumference. Okay, the diameter always subtends an angle of 90 degrees at the circumference. Right, I'm ready for my next one. Let's go. Okay, I'm ready. I'm ready. I want us to think about this together. This is a very interesting question. Can you please give me the letters that represent my radius? Please give me the letters that represent my radius. Can I please have the letters that represent my radius? CB. CB is definitely not a radius. The radius must start from the center. From the center. Okay, talk to me. Talk to me. AB. Radius, bafethu. What are you guys doing? Radius. 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 Nenzani. Nenzani. What are you doing? Welele. Thixo waseGeorge Koch. Radius. From the center. Okay. From the center. That's how it is. Okay. Now you're getting it right. Now you're getting it right. So, OC. OA rather, radius. OC as well. And OB. I'm good to go. Those are my radiuses. All right. They want X. I just wanted to just get you guys the whole idea. They want X. Can we agree that X plus 52 is 90? Phela AC is a diameter. And AC is subtending the whole of angle B. Because look at it like this, fam. Look at it. A line from A and the line from B. A line from A rather than the line from C. They meet at B. So the whole of B is 90. And your reason is angles in a semicircle. So it's angles in a semicircle. So the value of X should be 38. There you are. X is equal to 30. Thank you so much. I think people are getting this. The chat group is on fire, and I'm appreciating what you guys are doing. Well, write this down. Remember, you can always watch this on YouTube, and then we'll take it up from there. Okay, that was fast. That's not too difficult. So, yeah, boy. Yes, tell them, don't be Chuck Norris. All right, don't be Chuck Norris. Taking this out. Let's try the next one. Let's try the next one. I'm going to do this with you as well. This one's a very clever question. Do this with them as well. Okay, one more time. Radius. Don't embarrass yourself. Don't you dare embarrass yourself. Radius. Asam. I'm showing my radius. I'm showing my radius. Okay, let's hear you. Let's hear you. Let's hear you. A, O, O, C, and even O, B. Let's go. So OC, OA, OB. Look at it. I'm looking for Y. I'm looking for X. Yo, I have a problem here. Now, this is interesting. Very interesting, because I can make this work. And there's so many ways of doing this question. Look at triangle OAB. Let me call this A1, just so that it's easier. A1. A1, the one that I've just constructed, is equal to XY. A1 is equal to XY. Why is A1 equal to X? You tell me. Why is A1 equal to X? Let me see. Angles opposite equal sides. Yes, it's an isosceles triangle. Angles opposite equal sides. So therefore, A1 plus X plus 104 is equal to 180. But remember, A1 is X, so I can write, instead of writing A1, I can put X again, plus the X, check this out, is equal to, I think this should be 76 when you take 104 to the other side. So this is now 2X is equal to 76. So X is 38. That's what X is. X is 38. I'm loving your answers. Beautiful. Now, if X is 38, I'm now looking for Y. Do we agree that the diameter AC, there's AC right there, is subtending this angle at the circumference? So in other words, we're saying Y plus X is equal to 90 degrees. These are angles in a semicircle. So I already know what X is from the previous one, that's 38. So I think the value for Y becomes easier. Y is 52. There you are, not too bad. Straight up, we're good to go right there. Okay, write this one down. I'm happy about that. Let's keep going. Theorem number 3, still working it out. All right. I'm ready. Gone, 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 going. All right. This one is yours. All these letters. 3 minutes. Let's go. This one is yours. All these letters. One more minute. Hey fam, let's begin on this one. Let's see if we're going to win together on this one. I did send the links for the grade 11 and 12 WhatsApp groups where you'll get more information and more help, more documents. Let's begin. The center is O, suggesting to me that XZ or ZX is your diameter, and it will subtend an angle of 90 at the circumference. So A is equal to 90 degrees, angle at angles near semicircle. Angles in a semicircle. All right, perfect. So then using triangle WZX, I think I can find what B is. B plus A, which is 90, plus the 74 will give you 180. These are the sum of the angles in a triangle. So the value of B becomes 16. Okay, I'm good with that. Let me find C. Okay, I think I'll need to construct here for me to find C. I can call this Z1. I can call that Z1. Then this and this are equal because they are radius. So now I'm on triangle OZY. Then I say Z1 is equal to C, angles opposite equal sides. Angles opposite equals. There are many ways of doing this, by the way. So you might not have done this method that I'm doing, but there are many ways. So Z1 is equal to C. So in other words, Z1 plus UC plus U38 should give you 180. Those are the sum of angles in a triangle. So then it becomes 2C, right? Remember, fam, I'm going to take Z1 to the other side. Z1 is C, C plus C is 2C. Then 180 in this case, minus your 38, then you divide that by 2. So it's 180 minus the 38, which should give you 142, and you divide that by 2, that's 71. So C is 71. Finally, I'm almost there for the D. The whole of angle C plus D is 90 angles in a semicircle. So C plus D is 90 angles in a semicircle. C is 71. I can get D. D should be 19, all things being equal. That's what your D and all. So you need to construct in cases where you want, because you're allowed to. You're allowed. That's why in Euclidean, when you write your paper 2, you'd have the diagram on the left, like how it is on the screen here. Then you'll have spaces to write on the right. So then you can say Z1 there. So the examiner would know when he reads and says Z1, then you go to the diagram. Then you'll see it, oh, okay, the student wrote this as Z1. Because that's part of the only way to get the other answers. So you're allowed to construct and add more things and blah, 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 as long as it doesn't really affect your maths. So that's pretty much good. So this becomes your answer. At the end of the day, nothing too hectic on that one. Okay, did anyone get everything? Let me hear you. Let me hear you. Let me hear you. Talk to me. Yes, I did. All right, all right. All right, all right. All right. Others say yes, others say no, but others are on their way there. We're all going to win. Somebody's asking, say, is angle X which x, because I talked about the wall of x, an exterior angle of OZY. OZY. Angle x, I mean this angle. No, definitely not. All right, definitely not. The exterior angle of OZY is this one. Whatever this is, you can even call it O2. That's the exterior angle. All right. So perfect. I'm happy about this, and I am proud of you from there on. All right. You know how time flies when you're having fun? Time has flown, and guess what we're doing? We were having fun. Somebody's asking, where does 2C come from? Angithi, we said Z1 is equal to C. So instead of putting Z1, I put C now. C plus C, 2C. All right. There you go. And all right there. Somebody said, say, am I wrong to say C is 38? Yes, you are, because 38 is opposite ZY and C is opposite OZ, and ZY and OZ are not the same. Right there. Okay, family members, I only went as far as theorem 3. Guess how many theorems there are? 9. 6 more left. 9 theorems. There's 6 more left right here. So where am I going to do the 6 more? In my paid classes. Pay the money, get the lesson. Pay the money, get the lesson. So fam, again, if you're interested in getting to my classes, which is very, very simple to do, you will be able then to pull through and see this. Oh, somebody say you were called for this. That is such a beautiful thing to say. My word, that is such a beautiful, beautiful thing to say. Thank you so much. It sounds like God handpicked me for this. Atiena uNkulunkulu, wena Mr. X, ne? Please go and teach these students math. I'll give you the mind, I'll give you the words, I'll give you the charisma, I'll give you the energy. Go and teach them. Thank you. I really appreciate it. I actually think that's true. That's very true. So fam, listen, the lessons are available and all that, and there's more. Guys, you have no idea. I'm telling you, you have no idea how much more I have in terms of these things. You see, this was theorem 4. Theorem 4. Look at the question 5. Thereabout 7, right? 6, 5, 6, 7, 8, right there. 9, thereabout. Then from there on, look at 9. 9 was crazy, man. Then I had questions. These are all my students that I teach. See, these are all my students that I teach, right there. I do massive revisions every single year. These are all of them. These students get distinctions. They all go to varsity. These are the many people that I'm always in contact with right here and all. See, all my students right there, all of them teaching. This was a class of about 100, 150 students that I'm teaching. One of my smallest classes available. By the way, guys, I can help you, okay? I can save you. I can help you. I can save you. Big time. I'm that kind of guy. I don't know how we met, why we met, but I'll tell you, I think it's God's doing. God made us see each other. I'll put my number again so that I can add you into the WhatsApp group so that you can also get as much information as possible. See? So this is us, this is me. These are the questions that I was doing with them. These are the past exam papers. It's going down. All this I will be doing in the part 2, part 3. Remember, this part 1, I only ended up on theorem number 3. Ne? So I've got to do part 1 again, but this time I'm going to be doing theorem number 4, 5, 6, 7, 8, 9. Then I will be able to pull through. These classes that I have, the physical classes, I'm holding them in Johannesburg, right? By the end of the year. But I'm going to do a camp this year, huge camp, but I'll update you guys on the group. I'll tell you 4 months before it happens and give you all the details, and so that you guys can be able to get all that you need. Thank you so much for coming into my class. Thank you for trusting a stranger that you've never seen in your life. We only met on WhatsApp, and look at us, we're building a relationship, and it's only going to get better. I'm telling you. Talk to your parents about attending the classes. What I've done, family, what I've done, I've really made the classes cheap. I have. Last year, the classes were 100 Rand, the online classes. They were 100 Rands for 2 hours. This year, I've made them 50 Rand. This is because I'm saying it's easier if you come through. Ne? Let me show you. Let me show you what I mean by this. It's easier if you look at it. This was me last year. Ne? Hey, hold on, fam. Hold on, fam. Just giving the last announcement. There. This was me last year. Right? Look at this. I'm not lying to you. Look at this. Only 100 Rands for 2 hours. This was me last year. See, this was 27 July, 30 July. I was doing revisions for the September exams and stuff. But now I've made it 50 Rand. In South Africa, somebody is decreasing prices. In South Africa, there must be something here. So guys, listen, talk to your parents, come through. For the whole month of April, each subject will be 250 Rands. That gives you access to 5 lessons for 2 hours. Then for 2 hours each lesson, that means 10 hours would be 250. Then for another subject, physical science, again, 255 lessons, 10 hours. If you want to attend everything, it's going to be on 500 Rands. To those that are doing grade 12, let me give you a word of advice. Please listen to me. Our grade 12 learner, listen to me. Buffett, what you're going to write in grade 12, 65% of the paper in grade 12 is what you do in grade 11. I'm doing classes with grade 11s currently. And there's things that were in a Chuck Norris you don't understand. Things that are giving you a run for your money. You don't know. You don't understand. Rather, join the grade 11 classes as well with the grade 12. Yes, it's money because there's nothing really for mahala. While I wrote free class, I had to create the slides. While I wrote free classes, I had to sit down for 2 hours and do this. While I wrote free classes, I'm the one that was talking the whole time, writing the questions here, attending to you. I pay for the Zoom while it's free classes. I would suggest, honestly, you talk to your parents, you get them to understand the situation. This is the problem that I have with my people. My people are reactionary. In other words, you wait until it's almost September to start waking up and thinking, hey, I'm writing. And you've had me since the whole of January. You've had me. You still have me now. It's March. Suddenly, you want miracles, bushiri kind of miracles to be performed on your head in February. I'm not a prophet. I'm not a prophet, Mina. Heaven. You must be able, while you still have time, to use me. While you still have time, step by step, by step, by step. I hope you understand what I'm talking about. Your time is gone. Especially the grade 12, you don't have time. Nanbo grade 11, you don't have time at all. So whatever you need to do it now and do it quickly because time is something that you don't have. And I'm here to help you out. I'm dedicating myself to you. Let me stop the recording, then I'll unmute you. We have a chit chat a bit. Then from there on, we can call it a day. I want to go and see if Manchester City is winning against Arsenal.